For question 1, I'll start from the left-hand side, which is equal to 4 and 2 over 3 divided by 1 and 1 over 5. I'll change both fractions to improper, so I got 14 over 3 divided by 6 over 5. Then I'll change the division to multiplication and flip the second fraction. Now it's time to simplify. The 6 with the 14 both are divided by 2. So I get 35 over 9. This is equal to 3 and 8 over 9, which is equal to the right-hand side. In question 2, let the probability landing on pink be x. The sum of all probabilities must be equal to 100%. As a decimal, this is equal to 1. So I get 0.32 plus 0.13 plus 0.28 plus x equals to 1. X comes out to be 0.25. Now if I spin the spinner 200 times, the estimate number of times it will land on pink will be this probability by 200. So 200 times 0.27 will give me an estimate of 54 times. I'll start question 3 by finding the value of x. Now to find the value of x, I'll use the fact that angles A and B are interior angles, therefore they add up to 180 degrees. So 3x plus 46 plus 4x minus 27 is equal to 180. Simplify to get 7x plus 19 is 180, and then solve this to get x is equal to 23. Again, I use the fact that interior angles add up to 180 degrees. Now, from the shape, it seems like B is the largest angle, but because this is not accurately drawn, I will also find C as well. No need to find the other two, because B and C are the two obtuse angles, while A and D are acute ones. So angle B is equal to 3 times 23 plus 46, which is equal to 115. Now to find C, I'll first need to find D, which is 3 times 23 plus 10, which gives me 79. Therefore, C is an interior angle with D, so they add up to 180. Doing this subtraction will give me 101. All these are degrees. Therefore, the largest angle is B, which is 115 degrees. For question 4, I'll start by plugging the x values into the equation to get the y values. Now minus 3 will give me an 8, minus 1 will give me a minus 2, 0 will give me a minus 4, 2 will give me a minus 2, and finally 3 will also give me a 2. And then I'll go to my grid and plot those points and then join them with a smooth curve. For question 5, there are two things I need to consider. One of them is the number of coins of each type, and then the value of the coins of each type. And to do so, I'll create a small table to summarize my findings. Now let the number of 2p coins be equal to x, and because of the ratio 1 to 3, this implies that I've got 3x coins that have a value of 5p each. Now, since one 2p coin has a value of 2p, x of them will have a value of 2x pence. And similarly for the 5p coins, I've got 3x of them times 5p each will give me a value of 15x pence. Now, if I add those two, I will get 17x. But I know that this value should be equal to 85 pence, So if you do the division, x comes out to be 5. Therefore, I have 5 coins that have a value of 2p and 15 coins that have a value of 5p. And the question says, how many more of 5p are there? And the answer is 15 minus 5, which is equal to 10. For 6a, 76 million in standard form is 7.6 times 10 to the power of 7. And in part B, 5.4 times 10 to the minus 4 is 0.00054 as an ordinary number. For question 7, the angle AOC, the reflex angle AOC, I need to find is this angle here. In order to find that, I'll first find the angle AOC that is part of the quadrilateral AOCD, this angle here. Now to find that value x, I will first need to recall that the angle between a tangent and a radius is 90 degrees. Therefore, the angles at A and C are right angles. So I have the following: 48 plus 90 plus 90 plus x equals to the sum of the angles in a quadrilateral, which is 360. X comes out to be 132. So the reflex angle AOC is equal to 360 minus 132, which comes out to be 228 degrees. For question 8, I'll use the following formula. Final value is equal to the initial times the multiplier or multiplying factor. Now, the multiplying factor for each year is 104 over 100 because I have an increase of 4% each year. As a decimal, this is 1.04. Now, because there are 3 years, I'm going to raise this to the power of 3. Therefore, my final value will be the initial, which is 680 times 1.04 to the power of 3. Put this on the calculator. It's going to give you 764.91. Now, to the nearest dollar, this is 765. For question 9, I need to make a conversion between kilometers per hour and meters per second. Now I've got 27 kilometers per hour, so that's 27 kilometers in 1 hour. I just need to convert the numerator into meters and the denominator into seconds. Converting kilometers to meters is done by multiplying by 1,000, and then converting hours into seconds. You multiply by 60 to convert it to minutes, and then by another 60 to convert it to seconds. And then you put this on the calculator and the answer comes out to be 7.5 meters per second. Now for question 10, I'll be using the following formula. Mean equals to the sum, sigma x over n. Now you rearrange this formula, you'll get sigma x equals n times the mean, and this is the formula I will be using. I'll use this 4 times, twice for each team, once before and once after the extra rounds. Now I like to summarize all my data on tables, so I have one table for each team. So for team A, before the extra round, the mean score was 17 and this was obtained in 11 rounds. So the total score was 17 times 11, so 187 points. Now after the extra round, I had 12 rounds and the mean was 18.5. So the sum was 12 times 12 to 18.5, which is 222. So there was a gain of 35 points from the last round. Now for team B, the mean was 18 and this was achieved in 9 rounds. So 9 times 18 is 162. That's the score, the total score for the 9 rounds. And after the extra round, it got to 18.5 in 10 rounds. So it was 185. That's the total score. That was a gain of 23 points. So Team A achieved more points on that round than Team B. And how many more? 35 minus 23. That's 12 extra points. For question 11, I'll start by a common mistake done by students in this question. And this is to assume that triangle DEK is an isosceles triangle. Therefore, angle E here is equal to X. This is not an isosceles triangle. We have no such indication. So do not assume that this angle is equal to X. Now, to solve this question, there are various methods. In any method you decide to use, you'll have to find the angle, the interior angle of a regular polygon, and to do so, we'll use the following formula. And in this case, because we have a 9-sided regular polygon, I'm going to use this formula with n being equal to 9. So we have 9 minus 2 times 180 over 9, which gives me 140 degrees. And this is the interior angle of this shape. One interior angle that is of interest is the angle FED, which is this angle here. So let's mark it on the shape. Also note that the line joining this vertex and the center of the polygon divides this interior angle into 2. So this angle here is 70 degrees. And also I will need these 2 angles here. Now for both of those, I have angles on a straight line adding up to 180 degrees. So for this angle here, I have 180 minus 140. This is equal to 40 degrees. And similarly for the one above, I have 110 degrees. And finally, I can find X by using the fact that the sum of angles in a triangle is equal to 180 degrees. Now I'm going to write all my workings down so it is clear and I get my method marks. So angle ODE is equal to 140 divided by 2, which is 70. We said that this is the interior angle divided by 2. Then we said that KDE is equal to 180 minus 70, which was 110, angle on a straight line. And similarly for DEK, which was 180 minus 140, and this was equal to 40. And finally, angle X was equal to 180 minus the other 2 angles in the triangle, and this comes out to be 30. And this is my final answer. For question 12, I'll consider the 2 right-angled triangles of this shape, and those are ACD, which is this red one, and ABD, which is the whole shape. And then I'm going to extract this below so I can do my workings. So using the blue one, the large one, cos of angle A is equal to adjacent, which is 8, over the hypotenuse, which is 14. So A is the inverse cos of 8 over 14. A comes out to be 55.15009542. And then if I go to the red shape, angle A now is equal to what I found before, 55.15 and so on, minus what I'm given in the original shape, which is 38. So angle A in this red triangle is 17.15009542. And now to find the height of this triangle, to find CD, I'm going to use tan of this angle A, I'm not going to retype it, equals to CD over 8. Therefore, CD is equal to 8 times tan of 17.15 and so on. You have the answer of the angle, just put it in the calculator, type the whole thing. This will come out to be 2.47 centimeters. For question 13, for dice A, we have 2 red faces and 4 yellows. The probability of getting red is 2 out of 6, and the probability of getting yellow is 4 out of 6. Now for dice B, there's 1 red face and 5 yellow, so the probability of getting red is 1 over 6, and the probability of getting yellow is 5 over 6, and this is the same in both set of branches. For part B, to find the probability that we get 2 yellow, we just follow this path here and we multiply the probabilities along that path. So we have 4 over 6 times 5 over 6. Put this on the calculator and you're going to get 5 over 9. For part A of question 14, we need to find angle RQP. That's this angle here. And the answer for this one is 90 degrees because angle in a semicircle is a right angle. So let's write this down, 90 degrees and the appropriate reason. And then in part B, we need to find angle PSQ, which is this angle here. Note that these two angles are equal because angles in the same segment are equal. So let's write this down. The answer is 22. And let's write the reason as well. And that's it for question 14. For part A of question 15, let's split this into 2. So we've got 32 to the power of 3 over 5 times 8 to the 15 to the same power. And then if I apply the power to each term separately, I will get 8a, and then to find the power, just multiply these two, and you're going to get a power of 9. You can do the first part on your calculator. Part B, negative power, that's the first thing I'm going to handle. I'm going to flip the fraction, 10x over 1 to the power of positive 3. Now, as above, this is like saying 10 to the 3, x to the 3 over 1 to the 3, which will give me 1000x cubed over 1. No need to write that. Part C, lowest common multiple of 3, 5, and 2 is equal to 30. So I'm going to multiply the first fraction by 10, second one by 6, and the last one by 15. So I get 10, 1 minus 2y equals to 6 times 4 minus 15 over 2y minus 1. Now, I can, if I want, write down the common denominator in each side and then cancel it out, but no points are awarded for that, so let's just get rid of it. So now let's expand. 10 minus 20y is equal to 24 minus 30y plus 15. Let's collect all the y's to the left. So 10y equals to 29. So y is equal to 29 over 10. And that's the final answer. Now, if you want, you can write it as a decimal 2.9 or even as a mixed fraction 2 and 9 over 10. Question 16, I'm given that q is directly proportional to the square root of t, and in part A I need to find a formula for q in terms of t. So I know that q is proportional to the square root of t, so q is equal to k square root of t, where k is a constant of proportionality. Now, to find the value of k, I have to know a pair of t and q values. I'm not given a specific pair, but I'm given a whole graph. So I'm going to go on the graph and pick up a nice pair. Now, from what I can see, this one seems to be a nice clear pair where t is equal to 4 and q is equal to 6. So let's go back to part A. Let's replace q with 6 and t with 4. Now this will give me a value of k which is equal to 3. Now don't stop here. The actual answer, the answer that will give you the final mark is the formula q equals to 3 square root of t. Part B can be solved in various ways. Now the method I'm going to use involves the following. Q is increased by 20%, which means that Q2 over Q1 is equal to 120 over 100, which is 1.2. Now Q1 and Q2 are the original and the final values of Q. Now I want the percentage increase in T, so what I need to find is T2 over T1, and then if I find this as a decimal, I can easily convert it as a percentage. Now Q2 is equal to 3 square root of T2. I'm using the relationship found above. And also Q1 is equal to 3 square root of T1. And if I divide left with left and right with right, I will get Q2 over Q1 equals, the 3's will cancel out and I'll be left with square root of T2 over square root of T1. And now I can replace the left-hand side of this equation with the 1.2 I found above. So 1.2 equals square root of T2 over square root of T1. Let's square both sides. This will give me 1.44 equals T2 over T1, which is what I'm looking for. And if T2 over T1 is 1.44, then this implies that I have a percentage increase of 44%. As an alternative to part B, you can do the following. Let Q be equal to 100 and find the value of T. And then similarly, let Q be 120 and find the value of T. All this done using the formula found above. Now I'm not going to go through the calculations, but here T1 comes out to be 10,000 over 9, and here T2 comes out to be 1600. So the percentage increase in T is given by the formula 1600 minus the original value divided by the original value times 100. Put that on the calculator and it's going to give you 44%. For part A, I'll keep the first bracket and expand the first and last because they're identical and I know an identity to do that directly. So I get 3x minus 2 and then x squared plus 12x plus 36. And now let's expand 3x cubed plus 36x squared plus 108x minus 2x squared minus 24x minus 72. And let's simplify 3x cubed plus 34x squared plus 84x minus 72. For part B, I'll start by removing the square root. So w squared equals e plus g over ef minus d. Then I'm going to cross multiply and expand. So efw squared minus dw squared equals e plus g. The target is to get e as the subject, so I'm going to collect all terms that have an e on the left. EFW squared minus E, and all the rest on the right, so G plus DW squared. And then let's factorize on the left, E bracket FW squared minus 1, right hand side remains the same, and finally I'm going to divide by that bracket and get G plus DW squared over FW squared minus 1. Now note that an alternative answer is the following: minus G minus DW squared and then 1 minus FW squared. You get that one if at this point, instead of all the E terms going to the left, they went on the right. In question 18, I have 6 graphs. Graph A is a positive cubic. Graph B is a positive reciprocal. Graph C is the sine graph. Graph D is a positive quadratic. Graph E is the cosine graph. And finally, graph F is a negative reciprocal. Then I'm given 3 equations and I need to match each equation to a graph. The sine graph, as I said before, is graph C. Y equals minus 3 over x is a negative reciprocal, that is graph F. And y equals 4x cubed minus 5x is a positive cubic, which is graph A. In question 19, I have to complete the square. Now, completing the square involves the following formula. To be able to use this formula, the coefficient of x squared needs to be 1. So I will take a common factor of 3 from these two terms. So I will get 3x squared minus 2x, close the square bracket, plus 5. So now I can take this expression, come to the side, and apply the formula for completing the square. So x squared minus 2x is equal to x minus half of 2, which is 1, squared minus 1 squared. Now I'm going to remove the second bracket. So 1 squared is just 1. And then I'm going to go back to my original expression and replace the highlighted expression with what I found on the right. So I get 3 square bracket x minus 1 squared minus 1, close the square bracket, plus 5. And I'm going to expand the square bracket, not the regular bracket. So I get 3 times my bracket squared minus 3 and then plus 5, which when simplified gives me 3x minus 1 squared plus 2, which is my final answer. In question 20, I have 12 counters, 3 red, 9 green. We select 3 of them at random, obviously without replacement, and I want the probability that at least 1 red is still in the bag. Now, if there is at least 1 red still in the bag, it means that not all 3 reds are selected, and this is the probability I need. Now, this is equivalent to 1 minus the probability that all 3 are selected. And the probability that all 3 red are selected is equal to 3 over 12 for the first person to select the red one, times 2 over 11 since the number of red are reduced by 1, times 1 over 10 because again the number of red is further reduced by 1. Put this on the calculator and you will get 219 over 220, and this is our final answer. If you want to visualize this as a tree diagram, this is how your tree diagram will look like. And the probability of selecting 3 red counters is the product of the first 3 branches at the top. For question 21, I will use substitution and I will replace this x with 3y minus 1. So let's begin. 2 times 3y minus 1 all squared plus 3y squared is equal to 11. Let's expand the bracket. 2 times 9y squared minus 6y plus 1 plus 3y squared equals 11, which expands to 18y squared minus 12y plus 2 plus 3y squared equals 11. Now let's take everything to the left and simplify. So I've got 21y squared minus 12y minus 9 is equal to 0. Before attempting to solve this quadratic, I will divide everything by 3. So I get 7y squared minus 4y minus 3 is equal to 0. Now you can solve this quadratic either by using factorization or the quadratic formula or completing the square. I'll go with factorization, and the two brackets I get are 7y plus 3 and y minus 1. The first one will give me y is equal minus 3 over 7, and the second one is 1. Now I'll have to replace those two y's into the second equation to get the corresponding x coordinates. So the first one will give me 3 times minus 3 over 7 minus 1. So x comes out to be minus 16 over 7. And the second one is 3 times 1 minus 1. X comes out to be 2. So my paired solutions are the following. I'll start question 22 by considering the triangle ABC. Now I'll draw the perpendicular from B to side AC, and I'll call this D. Now I'm going to extract this triangle below so I can find angle A. To find angle A, I'm going to use the cosine rule, and I will rearrange this to get the following. Cos A equals to B squared plus C squared minus A squared over 2BC. Let's substitute the values in. I get 16 squared plus 9 squared minus 11 squared all over 2 times 16 times 9. Put this on the calculator and you will get 3 over 4. So angle A is the inverse cos of 3 over 4. And this comes out to be 41.40962211. Then I'm going to use the left right angle triangle from this blue triangle to find the side BD. So sine of angle A is equal to the opposite, which is BD, over the hypotenuse, which is 9. Therefore, BD is equal to 9 times sine of angle A, which is 41.4, and so on. Again, put this on the calculator and you will get 5.95294045. What I'm being asked to find is the angle of elevation of the point F from the point D. So I will need the right angle triangle FDB, which is the following. And again, I'm going to extract this below so I can work out the angle of elevation. I'm given BF is 10, and I found above BD, and this was 5.95. I have the full value at the top. So to find angle D, I'm just going to do tan of D equals 10 over 5.95 and so on. Therefore, D equals inverse tan of this fraction. Put this on the calculator and you will get a value of 59.221 decimal place. In question 23, I'm given a cuboid. I know the dimensions x, x, and 2 root 5 minus 3. I'm also given the volume. I need to solve and find x. Now, I know that the volume of a cuboid is length times width times height. So the formula I'm going to use is x squared times 2 square root of 5 minus 3 is equal to the volume, which is 13 plus 6 square root of 5. Now, to find x squared, I will need to divide. So x squared is equal to 13 plus 6 square root of 5 over 2 root 5 minus 3. Now, I'm not allowed to use a calculator, so I have to show each step of my working. And to simplify this, I'll have to rationalize the denominator. I'll do that by multiplying by 2 square root of 5 plus 3, both the numerator and the denominator. So let's multiply out the numerator. I have 26 square root of 5 plus 39 plus, and now I have to multiply those two numbers. Now 6 times 2 is 12, square root of 5 times square root of 5 is 5, and then I have plus 18 square root of 5. Now in the denominator I have the difference of two squares. 2 square root 5 times 2 square root 5 gives me 4 square root of 25, so it's 4 times 5. Then I get 2 root 5 times 3, which is 6 root 5, minus the same thing, and those will cancel out. And finally, I get a minus 3 times plus 3, which is minus 9. Let's simplify. Now, in terms of the numbers without the square roots, I have a 39 and I have a 60 here, so I get a 99, and then I have 26 root 5 plus 18 root 5, which is 44 square root of 5, and in my denominator I have 20 minus 9, which is 11. Now I can split this into two fractions, 99 over 11 plus 45 square root of 5 over 11, which simplifies to 9 plus 4 square root of 5. Now this number that I found is not my x, is actually my x squared, so I have to take the square root, but because we don't know how to take the square root of a third, I will use the fact that my answer is in this form. So this is my x, so I'm gonna replace x with this number, so I'm gonna have a plus square root of b squared is equal to 9 plus 4 square root of 5, and now I'm gonna expand the left hand side, which will give me a squared plus 2 times the product of a and square root of b plus square root of b squared, which is just b. Again, this is 9 plus 4 square roots of 5. Now, what I'm going to do on the left-hand side is isolate the numbers that do not have a square root, the terms that do not have a square root, and this is the first one and the last one. So what I am saying essentially is that a squared plus b is equal to 9, and the other term, the one that has a square root, is equal to 4 square root of 5. So starting from the red equation, I get 2a square root of b equals 4 square root of 5. b has to be equal to 5 and 2a is equal to 4, hence a is equal to 2. Therefore, x is equal to 2 plus square root of 5. Now you can verify the numbers we found using the blue equation. A squared is 2 squared, which is 4, plus b, which is 5, gives you 9. I'll start question 24 by drawing a rhombus to visualize my problem. Now I'm not interested in the correct orientation, I'm just drawing a sketch of a random rhombus. Note that the two diagonals meet at point M and they are perpendicular, and I'll start my workings by finding the equation of line AC. To find the equation of this line, I'll first need to find the gradient, and I'll use the following formula. Plugging in the values gives me 10 minus 5 over minus 2 minus 4, which comes out to be minus 5 over 2. So I've got y equals m x plus c, and I'm gonna substitute in one of the points A or C. I will go with point A, so I get 10 equals minus 5 over 2 times minus 2 plus C. If I rearrange, I'll get the value of C equal to 5. Therefore, the line AC has equation y equals minus 5 over 2x plus 5. Then I'll find the equation of line BD. Now line AC and line BD are perpendicular, so I will use the following rule. This says that the product of the two gradients must be minus 1, so the gradient of BD is equal minus 1 over the gradient of AC, and the reciprocal of minus 5 over 2 is 2 over 5, the negative becomes positive, so that's the gradient of line BD. So I get y equals 2 over 5x plus c. Now I don't have an option here, the only point I know on this line is point B, so let's substitute the coordinates. 4 equals 2 over 5 times minus 27 over 5 plus c. If you solve for c, you'll get a value of 154 over 25. Therefore, the equation of this line is y equals to 2 over 5x plus 154 over 25. Next, I'm going to try and find m by solving simultaneously these two equations. So by substituting one into the other, I get minus 5 over 2x plus 5 equals 2 over 5x plus 154 over 25. So 5 minus 154 over 25 equals to 2 over 5x plus 5 over 2x. Simplifying both sides will give me minus 29 over 25 equals to 29 over 10x. Therefore, x comes out to be minus 2 over 5. And now to find the y coordinate, I just substitute this value of x into any of those two equations. I will go with this one. So y equals to minus 5 over 2 times minus 2 over 5 plus 5. This will come out to be 6. Therefore, point M has coordinates minus 2 over 5, comma 6. The target is to find the coordinates of point D, and so far I know M, B, and I'm trying to find D. M is the midpoint, so I can use the formula for the midpoint, which is the following. My two endpoints are B with coordinates minus 27 over 5,4 and D with coordinates x and y. The midpoint is M, which I just found. Therefore, if I isolate the x and the y coordinates, I will get the following. X plus minus 27 over 5 over 2 is equal to minus 2 over 5. Solving for x will give me 23 over 5, which is 4.6 as a decimal. For the y coordinates, I get y plus 4 over 2 is equal to 6. Therefore, y is equal to 8. Therefore, point D has coordinates 4.6, 8. For question 25, I'll need to use the fact that density equals to mass over volume. Now I'm given two quantities, the radius and m, and I'm going to find the upper and lower bound of each. Now the radius is 2.8 centimeters, the lower bound of this is 2.75, and the upper bound is 2.85. Capital case M is given as 260 to two significant figures. The lower bound of that is 255 and the upper bound is 265. So the upper bound of the density is equal to the upper bound of the mass over the lower bound of the volume, and the upper bound of the mass is equal to 265 times pi. Now remember, mass is m pi, and now I need to find the lower bound of the volume. The volume is given by the formula 4 over 3 pi r cubed, and since I want the lower bound of the volume, I'll use the lower bound of the radius, which is 2.75. I can cross out the pi's, put this on the calculator, and you will get 9.56 correct to two decimal places, and this is our final answer.